Topic for this video is exponential expressions. So essentially what we're going to be doing is taking the exponent properties, the rules that we've already looked at, and apply these into expressions with variables in the exponent. So the first thing we want to do is get used to changing a base. So the base, again, is that number part of an exponential expression, the number that's at the bottom, and then the exponent is up at the top. In a lot of cases, it's going to be beneficial for us to change the base so that we can start to compare like quantities and eventually solve equations. So what we're going to be doing then, we're going to take something like 125 to the second power, which might be a little bit more difficult for us to calculate. I don't know off the top of my head what 125 squared is, but I can think of 125 as a power of 5. And so 125 is 5 to the third power, which then I'm going to raise to the second power. Squaring something means I'm taking something and multiplying it by itself. So 5 to the third squared means 5 to the third times 5 to the third. Using our power to a power rule, we can multiply those exponents distributed out here, and we get 5 to the sixth power. Now, that's great. That's wonderful. Really, the most important part of this, though, is to actually take this and use those properties on the exponential expressions. So something like number 4, when we have a 9, we can change that to 3 squared. Good part is our next step. The rules don't change. It's just that now we have variables in the mix. We're still going to multiply those two things together because it's the power to a power property. And so that's going to give us 8x for our new exponent. The more challenging ones are like 5 and 6, where we have something variable of x plus 7, or number 6, we have x minus 4. So what we're going to do is change that 27 to a base of 3. So I'm thinking 27 is 3 to the third power. So again, power to a power means we're going to multiply our exponents together. And this is the tricky part. I'm actually going to take 3 times the entire expression, x minus 4, and then I'm going to distribute. So it would be 3x minus 12. More advanced problem. So on these ones, what we're looking at is to turn this expression into something in this form, where we potentially have a coefficient out front, and then we have something to the base 2 taken to some power. So I'm going to start with number 8 here because I'm really going to apply those rules that we've already looked at. And 8, this one's not too bad, 2 to the 3x. It's already taken care of in that first part, this part right here. I don't have to change the base. The 16, though, I do need to change. 16 is 2 to the fourth power. So it becomes 2 to the fourth to the x plus 1. So again, using our power to a power, I'm going to take that expression, 2 to the fourth to the x plus 1, and distribute my exponent. Four times the quantity x plus 1 is 4x plus 4. And now what I have left is multiplication. So my rule of multiplication with exponents is that if they have the same base, I can just add my exponents together. Now the 3 is not combined with anything because it's not a base of 2, and I can't turn it into a base of 2. But the expressions that have a base of 2, these two things right here, I can put together by adding my exponents. So when I take 3x plus 4x plus 7, I'm looking to put like terms together. That's going to give me 7x plus 4. And that's my final answer. Same thing on 9, except now I'm dividing. So I'm going to change my bases so that they're like bases. I can't, even if it didn't say like turn into a base 2, what I'm looking to do is see if those two bases have anything in common. Can I turn an 8 into a 4? I really can't with exponent properties, and I can't do anything with a 4 turning it to an 8. So what I'm going to do is bring it down to the smallest element possible, which would be 2. So 8 is 2 to the third power, and 4 is 2 to the second power. Using power to a power, I've got 2 to the 3x minus 6, and in the bottom I've got 2 to the 2x minus 4. So my rule of division is to subtract the exponents. So once again, I'm looking at like terms, 3x and 2x. When I subtract those, gives me 1x. Negative 6 minus negative 4 means plus 4. That would give me a negative 2. So it becomes 2 to the x minus 2. Often in exponential expressions, we have a very special number that we can take a look at, and that's the number e, which we'll explore a little bit in depth, but really the heart of e is going to be later on in future classes. So the number e is a constant, right? It's an irrational number. It's the same, essentially the same thing as pi. It's some known number that is non-terminating, non-repeating. If we wanted to find out what E is, we could calculate it using this. And a famous mathematician named Euler came up with that number, or might have been named after him. I'm not 100% sure, but that's the official definition of the number E. Just like pi, we can use it to approximate certain things, and it can be approximated using whatever decimals we need. The decimal keeps on going forever and ever and ever. Just like pi, there's no real pattern to it. Right? And the algebra of E works the same as the algebra of pi, and it's commonly going to be used in calculus applications. So it's important for us to know for the future. The rules that we're going to use are essentially the same. Nothing's really going to change about this other than we have a defined base, which will be E. So we still want to have that coefficient, if we've got it, a base of E taken to some power. We're going to do number 18, because I think that's like the pinnacle of difficulty on these problems. So we're going to take this expression here, 3e to the x taken to the third power. So because I've got power to a power, I'm actually going to distribute that to my exponents. And then here in the numerator, I'm still going to leave that 2e to the x minus 4. And in the bottom, I'm going to leave the 9e to the x plus 3. 3 to the third is 27. So I'm going to use that in a minute. And then I've also got that 2 that's going to get multiplied by 27. That's going to give me 54. I'm looking at the numerator, and I've got my bases of e, and I'm looking to put those together because I'm multiplying. I'm going to add my exponents. So I've got 3x plus x minus 4 is going to give me 4x minus 4. Again, the denominator, I haven't done anything with that yet. It's kind of along for the ride at this point. So where I'm at now is I've got two parts that have a base of e, a numerator and a denominator, and I'm trying to put those together. So I'm going to start with my coefficients and look and divide 54 divided by 9, which just give me 6. And then my base e, because I'm dividing, I'm going to subtract my exponents. So 4x minus x is 3x. And negative 4 minus 3 is negative 7. So it's 6e to the 3x minus 7. The last part of what we're going to do is to take an expression that's going to have decimals and try and convert it to something in that form that we had before, a coefficient and then a base to some exponent. Now what's different about this is we're not looking for a whole number base. We're not looking for something like 2 or 3 or 5 or anything like that. So on number 21, we have 8.7 to the 2x plus 3. So what I'm going to try and do first is rewrite that kind of working backwards from my exponent rules. Knowing that if I were to multiply with the same base, that means I'm adding the exponents. I'm going to work backwards from that and break this apart to a multiplication problem. This is really 8.7 to the 2x times 8.7 to the 3. 8.7 to the 3 will end up being our coefficient. We'll actually calculate what that is in just a second. And then 8.7 to the 2x, I'm trying to write that in the form where I have a base with an exponent of x and then that coefficient. I'm going to rewrite this a little bit, 8.7 to the third. And this part right here, I'm actually going to write it as 8.7 squared to the x. Now my next step is actually calculate what those two expressions are. I'm going to do that here in just a calculate this. I'm going to use a calculator here. I'm going to grab my just a basic scientific calculator will work for this one. So I'm going to find 8.7 taken to the third power. So I'm going to type 8.7, take it to the third power, and this is going to give me 658.503. And so that's going to be my coefficient. Then I need to find my base. So I'm going to go back to my calculator. I need to find out what 8.7 to the second power is. pull that up. 8.7 squared is 75.69. So that would become my base, 75.69, taken to the x power. So that's my expression. All values rounded to 3 decimal places where appropriate. And that's going to give me my exponential expression.